Okay, so welcome to the first presentation this year at OCX EclipseCon. Thank you for choosing this presentation about Eclipse, about Initiative 31. My name is Heiko. I'm working as a software engineer at Vector Informatik. So we develop several Eclipse RCP-based products in our company. My department also develops one large-scale application where I'm one of the responsibles for the Eclipse platform. And I'm also kind of coordinating this initiative, which is not a Vector-specific project, but it's a project of the Eclipse IDE working group and several companies involved in that. So the project, this initiative, is about investigating options to... Sorry? Okay. It's about investigating options to modernize Eclipse SWT, or in general the UI UX of your Eclipse RCP-based products like the Eclipse IDE. Please don't take this term modernize to, let's say, literally, because I know that it's a rather subjective thing, especially regarding UI UX. I will explain to you in a minute what we mean with that, so which current limitations, drawbacks we see in SWT. And I will also give you an overview of the ideas that we have to overcome them, and in particular an overview of this initiative trying to do that. And at the end, we will also make a look into the future, how we want to proceed with that, and how you all can or should be involved into this. So let's start with a look into the community. This is a thread at Reddit asking why so many people hate Eclipse IDE. Of course, that's a rather provocative question, and of course, I do not hate Eclipse IDE. But it's interesting to take a look into such discussions to see what people complain about, what bothers them when using Eclipse or the Eclipse IDE. And one of the points that always comes up here is the UI. Of course, there are other things, but the UI is always mentioned, people complaining that it looks old, that it feels old and quite outdated. And that's also a feedback that we get from customers of our RCP-based products complaining about the look and feel and other UI-related aspects of Eclipse products. So one thing is that this is about look and feel, of course. We here have a screenshot. I hope you can see it at the Beamer image on the left side. 20 years ago, an SDK product, Eclipse SDK product on Windows. On the right side, one of this year. You see that, of course, it looks a bit more modern because Microsoft has updated the widgets that we use here, but in general it looks the same, right? You have the same colors used, the same general workflows and appearance of the overall application, and that's why people often feel that it looks like a native application 20 years ago and not in a native application of today. But it's not only about look and feel, it's also about, for example, maintenance. So in Eclipse SWT we adapt the native widgets of the operating systems, macOS, Linux, Windows. So we have these 3 implementations to maintain. We have different versions to maintain because these operating systems evolve. We cannot just say we support one version like we can do for a library that we use, but the operating systems evolve and we have to support all these versions. So this leads to a bunch of maintenance efforts that we have to do, which is hard to accomplish all the time. And it's also about customization. So of course, in terms of customizing the applications to the look and feel that you want, which is limited because of these many implementations that we have that all have to provide this customization support. But also what you hopefully can see here is on the left side, a tree view with small vertical spaces, on the right side with larger vertical spaces. And the difference between these two was that we started building against new macOS APIs, which changed this behavior. And then there was a huge discussion whether this is okay. Some people wanted to have the old appearance. Some people said, well, this is how the operating system things look like, so we should use that. Some said, I want to configure that. And to be honest, at least nowadays, why should each operating system prescribe how the UI looks, and when the appearance changes at specific points in time, why not have something default across all the operating systems for our applications and make the users customize to whatever they want to have? That's also how other applications do it, other cross-platform applications nowadays. So here's an example of the Eclipse IDE. So it's also a usually web-based IDE under the Eclipse Foundation. This is how it can look on macOS, and if we take a look at how it looks on Windows, it's basically the same. Of course, the menu bar is different because that's handled by the OS, but the contents of your window, of course, are the same. That's usual today for with the trend of web-based applications, because they, of course, have the same look and feel on all operating systems and a uniform look and feel. So that's how usually you would expect it from today's cross-platform applications. So when taking a look at Eclipse SWT, I have said that we adapt these native widgets of the different operating systems. These are example images from the Eclipse SWT documentation, so they are derived from running the same snippet of SWT code. They have the same code, but look differently on all operating systems using the widgets of that operating systems. And what comes with this, what we've seen are the challenges that we have an outdated look and feel, which people complain about. This is in particular a problem on Windows, where we have this very old API that we're using, leading also to an outdated look and feel. This also leads to limited configurability, because we kind of have to implement the least common denominator across all operating systems that we can just provide. So we're very limited in what we can provide in terms of customizability. And this also leads to problems regarding maintenance, because we have 3 implementations to do, to maintain, to validate. So I have here my Windows laptop, I also have a MacBook and a Linux machine to implement and validate everything I do on all 3 operating systems. We also have the problem of few maintainers. Of course, there are not so many people evolving this, and in particular the experienced ones are moving away. And we have a risk of regressions because of technical debt, because of less test coverage and so on, which makes it difficult to keep this alive all the time. So these are the challenges that we currently face, which we would like to overcome. And now the question is what we can do about that. And we had a discussion about this in the Eclipse IDE working group, what we want to do to try to overcome these limitations. And started first with defining the goals of such an initiative. So this is basically rephrasing the challenges we've seen as goals to kind of modernize the look and feel, lower maintenance effort, and improve configurability. But we also found very important constraints to meet in this regard. And the first one, and I think most important one, is to have low effort for adopters. Because if you have applications running on Eclipse SWT or the Eclipse platform in general, you do not want to adapt to a completely new technology stack. You want to have low effort, in the best case have the same APIs with the same behavior than before when having a different implementation that you can just replace, because otherwise you might directly think about moving to a completely different technology stack. A second thing is the cost of your technology that you're using, so in terms of money, in terms of maintenance and runtime. Of course, that's important that we meet the same constraints that we have today. And another very important aspect is capacities and skill set, because we have usually Java developers in our ecosystem. We have few of them because we're in an open source project. So if we find a solution that requires, let's say, 50 C++ developers for several years, that would probably not be our solution. So we definitely need to keep in mind what people we have at hand to do this work if we want to do it. Then taking a look at opportunities that we have at different approaches, we can span a range of different options that we have. I have 4 levels defined or that we've discussed here, but of course you can think of more. Starting at the bottom, we could say, well, we just keep the existing OS implementations. That would, of course, not fit any of our goals, but that's basically what we have to do right now anyway. At the other end of the spectrum, we would have a complete replacement of the UI stack with something modern. Let's say take a web-based stack of technologies, because usually today's UIs are developed based on web-based technologies. So we could say we just throw away everything existing and have a new implementation. But usually that would require your consumers to adopt to this new technology. Then, starting from the bottom, we could also say, well, one of the problems is that in particular on Windows, things look old. So why not start replacing with something new in the OS-specific system? So let's say keep the native implementations, but the Windows one, the Windows 32 one, replaced with the WinUI 3-based one to have more modern look and feel on Windows. On Linux, we basically have to do this anyway. We use GTK3 as a library there. We have to move to GTK4 anyway and make this modernization to newer OS-specific frameworks. But if we already think about having a replacement for one of these implementations, like the Windows one, why move to a new OS-specific one and maintain that one? Why not directly move to an OS-agnostic one? So the difference between now and back then, when SWT was invented, is that today we have the chance to use OS-agnostic frameworks, solutions that are not specific to an operating system, because they have good performance, good functionality, integration into the operating system that was not available back then. So if we do the effort, why not directly move to such a solution? So the difference between the topmost levels is that the topmost one would rather be a migration approach where your adopters need to migrate their code to a different stack, which would not fit this constraint I mentioned with low effort for the adopters. While this level would rather be a modernization approach so that you could replace the SWT implementation and do not have any effort for your adopters, or as low as possible. And the difference between the bottom ones to the third one is rather obviously that we come from 3 to 1 SWT implementations because we do not have these 3 implementations for the operating systems as we have now, but only one OS agnostic one. So for these mentioned reasons, we found this level of approach rather interesting to take a look into it, whether there really are these technologies that we could use today to benefit from having just one OS agnostic implementation of SWT. And then we found that on Linux, I said we have GTK4, or currently GTK3 used as a library, and GTK basically can be used on all operating systems because there are ports for Windows and macOS existing. So that could also be an approach to have some kind of OS agnostic implementation. And there was already an approach some years ago to do this. So there was a Windows port used based on GTK for using SWT. In that case, to use theming support of GTK. And we revived that one and found that it worked pretty well. So what you see here on the right side is Win32-based Eclipse IDE. So that's how it looks like when you start your Eclipse IDE on Windows. On the left side, you see one that is based on GTK. So this now runs GTK library on Windows. You see that most things look the same. You see slight differences because, for example, the margins, the spacing in the widgets is a bit different. But the thing is, most things work out of the box. There were only really slight tweaks necessary in the SWT code at 1 or 2 places to get this running, and also many of the functionality you need in your UI. So this was impressive for us to see because we found that if this might be possible with GTK in such a good way out of the box, maybe there are even other technologies that fit even better than this one. And one other interesting aspect here is the Eclipse IDE, of course, is like a cross-platform product, right? We do it for Linux, for Windows, and for macOS. We at Vector, our product called Prevision, is a Windows-only product. So we only build it on Windows machines for Windows operating systems. So I thought if I would try to run it on GTK, it would never work because of dependencies to OS specifics. But I tried, and I only had, I think, 4 or 5 places of code, really only 4 or 5 places where we used font-specific customization on Windows that I had to remove, and then the application started. So even for operating system-specific applications right now, you could move to GTK, which was really impressive to see. Of course, we have some Windows-specific other stuff that is integrated that we currently could not use on GTK, but the overall UI is working pretty well. Please note that this is just the out-of-box appearance. So I've been talking about modernizing look and feel. This is not a better look and feel than we have right now. But of course, moving to a single implementation would improve would be an enabler and improve the chance to use customization support to better customize your applications. So having seen this, we were quite convinced that it is an option to take a look at OS agnostic solutions, take a look at the range of technologies that we have out there to find out whether we could really make it with this way. And that's where this initiative started, where we said in the working group, well, let's try this out, let's give it a look into the technologies out there and see whether there is something that might be feasible to do this. So we started with this initiative called Initiative 31. Now I have a question to you. So for those of you who have thoroughly listened, probably you can guess or even know why this one is called Initiative 31. So any guesses from your side? Exactly. So you said we're going from 3 implementations to 1. You have probably listened even though it's early in the morning. That's great. So yeah, it's about now having 3 implementations of SWT, 3 native implementations going to 1 OS agnostic one. So you could also say it's Initiative 3 to 1 or whatever longer term you want to use. But one important point is, for those of you who may be concerned that we come up with a new implementation next year and you have to adapt to that, the goal of this initiative currently is not to make this implementation. The purpose currently is to assess whether there are technologies that we can use to have such an OS agnostic implementation meeting these goals. So this, what we're doing here, is prototyping work. There are people working on prototypes to find out whether these technologies could fit, to then go into the discussion, and that's what we're doing starting from today, whether we should follow any of these approaches and really make it a project with a productive implementation as a goal. So that's important to say. When we started this prototyping work, of course, we first thought about what criteria do we have? So when do we identify a technology as potentially fitting? What should we investigate in such a prototyping phase? And there are some things that are rather obvious. So regarding functionality, of course, we need some kind of Java bindings to use it from our Java code, or we need to provide them. We need to have a browser integration. That's a rather crucial part, because in Eclipse applications, you need a browser to properly use them. So you need to have some chance to integrate in any kind of browser. And of course, the most obvious one is we need to fulfill the existing APIs, but also the OS-specific ones. So there are some things specific to operating systems. So for those of you more technically involved, for example, on Windows, you can use multiple instances of the display class. And of course, if you have a union of all your operating system implementations into a new OS-agnostic one, you have to support everything that is provided by the existing ones. This also applies to native window handle integration, for example, and also other things. There are also rather, let's say, qualitative aspects, like having matching licenses. Of course, we need to have an open source compatible license. It has to be mature on the operating systems that we support right now. And it, of course, has to be future-proof. It has to be actively maintained, widely adopted, because we want to have a solution that is sustainable for many, many years, and do not want to adopt in some years again. So these are the very important criteria to investigate. We also have some, let's say, optional criteria, like having technologies used in other open source projects, because then they seem to be usable in an open source context. You're kind of in the same boat. And one thing that could be interesting is the executability within a browser. So for example, via WebAssembly. That's also a starting point that we have when we would be able, not as the standard deployment, but as an option to have an ad hoc deployment of your applications for testing demonstration purposes in the browser. That would be a very interesting use case for many of the parties involved into this project. So we started with a paper-based pre-selection of technologies, because many of these criteria you can just check on a paper base. So general exclusion criteria were that technologies are not non-cross-platform, they are commercially licensed, or outdated, not widely adopted, which to be honest is of course a rather weak criterion. And then we had a whole bunch of technologies that we could directly drop. The list was even longer than this one, but many technologies could already be dropped based on these selection criteria. But of course, we also found some technologies that we wanted to take a look into, and did take a look into, which I want to give you an overview now. These are 3 technologies that we so far took a look into. The first one is no surprise to you. It is GTK. I've shown that to you already. For GTK, an implementation already exists that makes it usable out of the box. We have existing ports for Windows and macOS, and GTK also have native customizing support via CSS. So for the customizing aspect, that's also great. And one thing regarding GTK I already mentioned is that we have to move to GTK4 anyway. So putting effort in this, getting knowledge about GTK is something good, because we need to make the move to GTK4 anyway. Then second technology, and please don't be surprised, is Java Swing. Why Java Swing? So some might think, well, really outdated technology. But the thing is, so one thing is that IntelliJ is still based on Swing. They did a UI refresh some years ago and still using Swing for this. That's also the reason why, for example, many themes are out there, with which you can theme your Swing-based applications, because so many people are, of course, using IntelliJ. But another very interesting aspect in this technology, as a representative for other technologies, is that it's purely Java. So from a skill set and deployment perspective, that's really great if you only have to implement things in Java. It's also great from a platform independence perspective, because your system just has to support Java. You need a Java runtime with Swing support to run your applications on. And also for Swing, a partial implementation exists. So I think 10 or 15 years ago, people tried this and started to work on SWT implemented on Swing. And this is something that you can still revive and use. And also modern important things like theming, high DPI support, SVG, that we do not even have in our current implementations, are greatly supported by Swing. Then the third technology that we took a look at is Skia. Skia is a rendering engine, a graphics rendering engine used to draw primitives like rectangles, text, and so, used by many applications. Like, so it's developed by Google, used in Chrome, but also in open source context like Mozilla Firefox, Thunderbird, and also LibreOffice. But as I said, it's a graphics engine, a graphics rendering engine, so you do not have any widgets in there. That's the problem here. So we took a look at existing widget frameworks in applications also using Skia. There is, for example, LibreOffice using Skia and having, of course, widgets to run their applications. But you could also think of custom drawing widgets. Of course, it's a matter of effort, and I will come to that point in a minute, but we found Skia as a technology so interesting, used in so many tools and providing so many opportunities that we wanted to take a look into this. So the benefits are that you have a modern and really widely adopted rendering engine that you can rely on. You also gain platform independence because you only have to have Skia support on your platforms. And when taking a look at custom drawing widgets, you also have the benefits of pure Java because you implement your widgets in Java, so that's great from a skill set perspective. And you gain full control and flexibility. Of course, this comes together with the effort part, but the good thing here is there is very few chance that you run into conceptual problems at some point in time when you see that your framework does not support some feature that you need because you implement everything on your own or everything not relying on the graphics rendering engine. So you basically have full control and full chance to implement everything. So this as the overview with the key benefits of the technologies. And now I would like to give you an overview of what we achieved in this prototyping work. Of course, we focused on finding out specific points, whether we can meet them, all this criteria. But I will first want to give you an overview what you can do with the current prototypes to see where we are so far. So starting with GTK, I told you that we can run Eclipse applications on GTK on Windows. And to not only see a screenshot, I would like to also show it to you in a live demo. So we here have an Eclipse application. Here we have a GTK Windows 32 fragment. So this is the one that is not existing right now, and we can start an application, an Eclipse application from this. I think the splash screen will probably look a bit weird, at least when using it. Yeah, so that's quite weird. But the application starts, and you see that you have an ordinary Eclipse application running. Everything is basically working as expected. So I will not go into details here, but you can also use all the dialogues, you know, and so on, navigate through your IDE. So everything is basically working as expected, and you can directly try this out. The code is available. That's yeah, directly usable. So this is the GTK prototype running on GTK 3. I mentioned that we have to move to GTK 4 at some point in time. We tried that as well for the Windows port. Of course, it's broken, but not because of the GTK support on Windows, but because GTK 4 support is not generally implemented in SWT, so it will look similar on Linux. And even on macOS, we got the port running, and at least we're able to start SWT snippets also based on GTK 4 because there is no GTK 3 support on macOS. So GTK, as there is an implementation existing, can be used quite out of the box here. That's great to see. Then we took a look at Swing. We did not put too much effort into this because there was this existing implementation which had many things already implemented. So what you see here is the control example of SWT. That's an example where you can see all the basic widgets provided by SWT, try them out, what functionality they have, and this is run via Swing, so you see that things are working quite fine. I can also show that to you in a live demo. Starting the control example here, you see that not all the code is compiling. There are several problems in there. This is also why Eclipse applications do not run that well, but you see here that your SWT control example is working. You can use everything like you used to, which is quite good because at least SWT, plain SWT applications are running quite well based on Swing. If you try to run Eclipse applications, they still look rather broken. So for example, here you see that icons are missing and some other things are not working fine. There is still some work that needs to be done, but in general you see that on SWT it is working. And what you've also seen is that theming works. You've implicitly seen that in the demo I made. You can just apply any existing Swing theme that exists out there and have it applied to your SWT-based application. So you do not have to make any customizing on your own, but just apply the Swing theming and things will work like this. Then I said next technology, the third one is Skia. First of all, with an existing widget framework. We started with the one in LibreOffice. The library in LibreOffice is called Visual Class Library, short VCL, which provides the widgets used in LibreOffice. It was really hard to get things running first because it's really tightly integrated into LibreOffice, so we had to use the C++ code in there, the according APIs, using inter-process communication to get things running, but we finally did it. And here you can see two of simple SWT snippets with a button, a progress bar that are working. So these are SWT Java code running, but using the widget framework of LibreOffice. But even though this was possible, it was quite a long path until there, and you really need some specific knowledge in C++ in this communication part and so on, which is why we found this solution to be rather unsuited, because it does not meet these constraints that we had before regarding skill set and so on, and efforts. You also have some limited configurability, which is comparable to SWT, so we do not have any real gain in there. And I already mentioned the complexity part, but also VCL is tightly integrated into LibreOffice, so you would have to extract that from LibreOffice, you would have to maintain that, and there might also be a problem from a governance perspective, because the people must be willing to extract that from their tool, so that other applications can also rely on this VCL library. So that's why we dropped this solution. But we found Skia so interesting that we moved on, and the same people working on this then worked on custom drawing widgets, so trying to get things running in a custom way. And it was very impressive to see the gain in productivity and in motivation when they were using technology that they're used to. And pretty fast they were able to implement button, text, and label in a custom way, in an at least basic way. So not everything is working, but the overall look and feel is there, the basic interactions, clicking on things and so on is working. And you can start a usual control example from SWT with this. Of course, you now have a mixture here of native widgets and the custom drawn ones, but that works quite fine. You can also start Eclipse applications in such a mixed mode. You even do that right now because there are custom widgets existing right now as well. But replacing these native widgets is also possible, and this shows that we can also follow an incremental approach here. So let's say if you have fully implemented a custom button, you could just throw away the existing implementations, the existing native ones, and replace them with a custom implementation. And this is something I can also show you. So we have the implementation here based on custom widgets, first of all. But also using Skia as a rendering engine underneath, so I can even start an Eclipse application here. So if you start, you see that everything basically looks the same, because in the usual UI there is nothing using these exchanged widgets that we have, so the button, the text, and the label. But if I, for example, start a Java project creation dialog here, then you see that most of the things in here are custom rendered. So every text widget, every button, so all these checkboxes, radio buttons, and so on are completely custom drawn. And you can just use it like you're used to. So it will probably work here as a hot replacement of your existing implementations. Of course, this looked rather like the existing Windows implementation. We implemented them in that way, but you can style them in any way you want, because you write the code for styling them, of course. What you can also do is to exchange the rendering engine underneath. So what you've seen before is using the Skia rendering underneath, but in the screenshots here, not sure whether you can at least guess it, they look a bit different. On the left side you have the Windows renderer underneath, on the right side you have Skia rendering underneath, all using the same widget implementation, the same drawing, but a different rendering engine underneath used to generate these UIs. So that also allows you to hot swap even during runtime, but also to make a migration based on the native rendering and then later on switch to a completely Skia-based rendering, for example. So this was pretty impressive to see, also how fast it was possible to do a custom implementation of some of the widgets. Then, of course, we did not want to implement these things I meant before, but we wanted to assess whether these technologies are fitting or not. So we made an intermediate assessment. We would like to have come to the point until now to say that one technology fits best. At least we're already at the point where we say some may fit better than the others. So we would say that the last solution that we've seen, we've tagged here as likely suited, while the others are tagged as potentially suited, because there are some more points that could be showstoppers in general. That's why we need further necessity for investigating them. So one very important point here is the native integration of handles, of window handles, of browsers in particular, which we need to investigate. Also points like performance for GTK. And for this custom drawing thing, the most important point, as I said before, is the efforts. How much effort will it be to implement all these widgets on our own? And that's why we will focus in the next time on implementing at least one of the widgets completely to see how much effort that will be to extrapolate to all of the widgets. But some general findings that we had is that we should in general prefer a solution that requires low specific knowledge. So for example, having Java-only technology stacks is good from a skill set perspective and from a motivation perspective. And it would also be good to have a solution that separates the graphics engine from the widget implementation. So what we have right now is we have to implement, exchange everything at once. But going with a solution based on Skia and some widget framework on top of that, you could just exchange Skia whenever you want. I've shown that in the example before. You can use native rendering, Skia rendering, or anything else you want. That's a real opportunity to then be able to independently exchange these two parts, the graphics engine and the widget framework. So that said, now let's look into how we want to proceed with this. Let's first take a look at the timeline for this. So we started with all this at the beginning of this year, generating the idea, discussing it also with Eclipse project leads, and building this first GTK prototype. Then we moved into the prototyping phase, starting at the end of May, where we started the evaluation of these three technologies, having weekly meetings, having these 4 companies involved. Many of the people are also here, so you can talk to them. See what they found out in that time, and at this point I really have to thanks to everyone involved in this so far, because it's really great to see what we all did in these 4 months and what insights we gained. And as I said, for the next time we want to slightly extend this prototyping phase, putting focus on very specific criteria to find which one fits best, but we want to have a decision by the end of the year saying which of these technologies fits best, and in the best case also to decide how to move on. To decide whether we want to have an actual realization based on these technology or not. And that's why we will also have an interested party call at the end of November, where we invite all of you to just join, share your interest in this, share your interest in contributing to it, because we need to see how many people also have interest to work on this, because of course it will be more effort to make an actual implementation than just doing the prototyping work. So if you're interested, just join us in this. If you're interested, also take a look at the resources of this. So everything I've shown to you is publicly available. So we have this GitHub organization here where you can check out the codes. There is a prototyping code that you can try out if you want. There is quite some documentation regarding the organization of the project, but also with reports for all of the technologies with much more details than I've given you today. And also this intermediate assessment of the technologies that we have seen. So, as I said, we invite you to join this initiative because we all currently have the chance to either accept everything as is and say, well, you can also say it's fine for us like it is. We accept the situation. We do the maintenance work that we need to do. We can also each find our migration or modernization paths on our own. But to be honest, we're in this community because we're sharing efforts. We're together working on Eclipse, driving the platform. So let's do this also together and find a common modernization path all together, so that not each of us has to do this on their own. So if you're interested, as I said, check out this GitHub page, join our interested party call, and contact either Thomas, who's sitting in front here, the program manager of the IDE working group, or me for more details, for getting involved, and so on. We would be very happy to hear of you, to have your interest in this initiative. So to summarize, I've given you an overview of this initiative with having the goals of more modern look and feel, lower maintenance effort, and higher customizability in SWT. I've given you an overview of the achievements, what we can do with the current prototypes, what we found out so far. I've given you a pointer to the resources. And to close, I have mentioned the call to action. Let's share efforts together, join our interested party call. Here is a code that you can scan to register for that call that we make, and we will also have a BOF session today evening about the Eclipse platform IDE in general, where we can also discuss this topic if you're interested. We will be here all the conference, so come to us, talk to us if you're interested. We are happy to get your feedback, and for now, thank you for your attention. And I think we're almost out of time, but if you have one question or so, maybe you just want to have... We have more time? Okay, thank you.
My question would be regarding the API. Would you also then allow, when you have decided on one of the three or whatever will come up, that libraries, you know I do GEF, can then also access the underlying rendering engine to maybe do better drawings, or you would like to really isolate that like it's now through SWT?
So the question is, whether you can then access the graphics engine. So actually you can already do that right now, because it will be nothing else than directly using the GC, the graphics canvas in SWT to render things. So that's what we also did in our implementation, to have a new implementation of this graphics canvas based on Skia, for example, as a framework, which currently uses the native implementation. So that would be an ordinary way to access that. Of course, we can think about giving more direct access to have less indirections for performance reasons or whatever. Not sure whether it would be reasonable to have a direct access to a specific library, because that would reduce interchangeability, but if you want to use it, why not? So since Skia, for example, would be lying underneath, if you want to have it in your applications, no one will prevent you from accessing that library that is provided there. Okay. Any further questions or comments now? Yeah.
Thank you. So GTK and Swing are pretty good when it comes to accessibility, navigation with screen readers, keyboard only, mouse only. Is Kia coming with such features available by default, or would they be to be implemented as well?
So it's an important point to see, to take a look at accessibility support. So to be honest, we have not taken a look into that, but we have it on our list. But the thing is, since Skia is only a graphics rendering engine, probably there will be no such integrated support. We have to take a look at that and see what we can reuse from the current implementations for that. So yeah, to be honest, the point that we have on the list, but no good insight so far. Okay, anyone else? Last question, Thomas says. If not, then thank you again and see you at the conference.